Good day, folks, and welcome back to Math with Captain Rod here. So making this video here to work on our notes here on in Chapter 2. We're going to talk about properties of graphs. Let's see, list the properties that these equations have if they have the following symmetries, basically. So when a graph is symmetric about the x-axis, that means that, get my pen on here. That means that if the point A, B is on the graph, then the point A minus B is also on the graph. And I'll give an example of what I mean here of that in a minute. The A's and B's can be any values. So for example, if the point 2, 3 is on a graph of some function, and that function is symmetric about the x-axis, then the point 2 minus 3 also has to be on that graph. An example, if you think back to like parabolas, those horizontal ones, there's an example of that. You know, maybe the points 2, 3, and 2 minus 3. All right, y-axis symmetry. Pardon me. So if we have a function here that's symmetric about the y-axis, that means this: if the point A, comma B is on the graph of the function, if it's symmetric about the y-axis, then the point minus A, B is also on that graph. Numerical example of this would be, if the point 3, 1 is on this function, the point minus 3, 1 is also on the function, or on the graph. So, example of that, maybe some sort of parabola that opens this way. 3, 1, not to scale, minus 3, 1. So again, not to scale. And again, these are just quick little sketches to kind of demonstrate what that looks like. All right, symmetry about the origin. So if a graph is symmetric about the origin, that means that if the point AB is on the graph of the function, then the point minus A minus B is also on the graph. So for example, if the point, 5, 2 is on a graph of the function and it's symmetric about the origin, then the point minus 5 minus 2 is also on there. Graphs that are symmetric about the origin kind of look like this. Here's an example of a graph that's symmetric about the origin. Whoops. Oh, can't see the backwards button there. Here's a sketch of something that's symmetric about the origin. Again, just to make up an example here, imagine 5, 2 is on there, then minus 5, minus 2. Or maybe 1, 1, minus 1, minus 1, and so forth. So these are just quick little graphs here. This is the big important stuff to understand. All right. Next part of the notes here, where it says match the symmetry to the correct picture. Okay, so what I'm going to do is go through this and talk about the different types of symmetries. So if you look at this graph, let's look at this point and this point. And one of the examples that we talked about above is the point AB and the point A minus B. So here we have an X and a Y, same X minus Y. This graph is symmetric about the x-axis. So it has x-axis symmetry. Take a look at this one right here. So you'll notice the point xy is on the graph, minus x minus y. Right? That was the test for symmetry about the origin. This animal is symmetric. Let's see, we've got an xy, we've got a minus xy. This one is symmetric about the y-axis. Now, in this picture, I'm pretty sure they meant this to be a right angle. It doesn't really look like a right angle, but it was, cut and pasted in here some sort of way. I'm pretty sure that this is intended to be a right angle symmetrical picture. And you'll notice here, like if I pick a point right here, you've got the point A, B, and you notice this same point here, minus A, B, and that was the test for symmetry about the y-axis. So this has y-axis symmetry. Take a look at this one. Here's the point like A, B. And you notice that minus A minus B is on there. Like, same distance left and down, so this one is symmetric about the origin. Oops, sorry about this here. All right, taking a look at this guy. And again, you'll notice that this is a reflection about the x-axis, AB, A minus B. This one is symmetric about the y-axis. Pick a point here, AB minus AB. This one is symmetric about the y-axis. Pick a point here, I'm just calling this like AB, and notice that minus A minus B is on here. This one is symmetric about the origin. Okay, this animal is not symmetric about the x or the y or the origin. I do believe they mean this to be a 90-degree angle. It does have a symmetry. It's symmetric about an axis that goes through the vertex. You know, this is some point, let's say AB. This one is symmetric about x equals A. I think in the context of the notes here, there's no x, y, or origin symmetry is what they meant by that. Okay, where it says equations that are considered something functions, find all examples above. Not having written this, I'm not sure what they mean, but I think it's referring to properties called even and oddness, right? When functions are considered even, and I'll make a video about what even means here aside from this, then they are symmetric, they are considered, whoops, actually no, I'm sorry. When functions are even, they are symmetric about the y-axis. Functions that are symmetric about the origin are called odd functions. And again, I'll make another video about what these mean. Okay, where it says find all examples of even functions. All right, let's do that. I think what I'll do is I'll color code this. We're going to put evens in green. So anything that's symmetric about the y-axis is an even function. That one's an even function. This one is an even function. That's it. All right, let's talk odds here. And I think what I'll do is, oops, let me go back here. Again, evens are color-coded in green. I'll use red here for the odds. All right, so this one right here is an odd function, anything that's symmetric about the origin. So that one's odd. When I teach algebra, I call them even Steven and odd Todd. This one is symmetric about the origin. That's an odd function. Neither of these. Any more up there? This one's neither even nor odd. This one is an odd function. It's symmetric about the origin. Oh, I missed one. I missed an even one here. This one right here is symmetric about the y-axis. That one's even. Ooh, I don't know that I have the color here. I think it was this one. Yep, cool. All right, there they all are. Greens are evens, reds are odd. Let's move on. And again, there's a mathematical test for even versus oddness. Probably not in these notes. I'll make a separate video for it. All right, translating graphs horizontally and vertically. I will probably make a separate video about this. I'll just do what they're saying here and talk about the equations for it, but let me do the vertical one first. This one makes a lot more sense. If I have a function f of x, and I have another function, let's say h of x, that's equal to f of x, the first function, plus some value, let's say k, where k is some number, 3, 4, 5. Here's how these are related. If k is positive, h is a graph of f of x raised up by an amount k if k is positive, down by an amount k if k is negative. So the quick example here. If I took this function right here and I had f of x plus 2, this point would go up 2, this point would go up 2, this point would go up 2, and so forth. Okay, for horizontal shifts, if I have a function f of x and I have another function h of x, which is equal to f of x plus h, and I'll give examples of what that means here in a minute. The graph, the relationship between h and f is this. You take f of x and you shift it left by an amount h if h is positive, right by an amount h if h is negative. And I'll give examples of that here, I'm sure, in a minute. So, when we take a look at this guy, if we had another function, let's say h of x, that was equal to f of x plus 2, this point would be moved left 2 units. And then this one will move left 2, and then this one will move left 2, and so forth. If it were x minus 2, this point gets moved to the right 2, this one to the right 2, and so forth. And again, I think what I'll do is I'll make separate videos on these horizontal and vertical shifts, or translations. Okay, example 1 where it says write an equation for a right horizontal shift of 2 units. So what they're saying is here's some function, f of x. The new function, I'm going to call it h of x, is going to equal this guy shifted right 2. Mathematically, that's f of x minus 2. Horizontal shifts work backwards of the way you might think. Vertical translations hopefully work just the way you would think. Add a value of k to it, it goes up by an amount k. Subtract k, it moves down by k. Horizontals work a little backwards of that. And again, you'll see, I'll make a separate video as to why, but when this term's positive, it ends up shifting left. When this term's negative, it ends up shifting right. Let's see where it says draw it on the picture at the right. So this point would go to here, this point would go to here, this point would go to here, and all I did is shifted those points right too. And I'll just sketch the rest of it. Whoops, and this is my example from earlier. This is now equal to f of x minus 2. All right, next one. Write an equation for a vertical shift down 4 units. So here's what they mean. We have some new function h of x, which is equal to the old one shifted down 4 units. Draw it on the right. So every point on this graph will be shifted down 4 units. So this one will go to here. This one will go to here. Let's see, this one, I believe that's at plus 2, is going to go down 4 units. That'd be minus 2. This is just a sketch. That one could have been better. Sorry. So here's a graph of f of x. Here's my new graph h of x, which is equal to f of x minus 4. All right. These are awesome. Write an equation for a horizontal shift. Right 4 units and down 2 units. So my new function h of x. You might wonder, why am I calling it h of x? You can call this thing anything you want. Z of x, r of x, k of x. I just like saying h of x. What you can't do is call it f of x, because it is a different function. Okay? It's a function that we would get by taking the first one, f. Now let's see. Horizontal shift right 4 units. So that means we're going to have an x minus 4 inside of here, and then a vertical shift down 2 units, so minus 2. Draw it on the picture. All right, so every point has to shift right 4 and down 2. So this point right here, right 4, down 2. This one right here, right 4, down 2. That's going to put it right on the origin there. Let's see this one, which I believe is negative 4, 2. Right 4, down 2. And again, that point I translated was this one right there, which I believe to be the point negative 4, 2. Now we can sketch it. All right, so there's a graph of our new function, which is f of x minus 4 minus 2. Okay, video's at 15 minutes, folks, so I think what I'm going to do is stop that right there, and I'll start a new one here about reflections about the x and y axis and whatever comes after that. So take a break, grab some popcorn, have a great day.